Okay, for 11.1, where our learning goal is, I can find an arc lengths and use them to solve real-world problems. We've already found arc measures, so we're going to now find arc lengths. And it's important to know the difference between those two, and we'll talk about that here in just a minute. Before we start, though, we'll just review circumference really quick, right? Circumference is the distance around a circle. You guys have been finding circumference for a long time. There's two formulas. Right, you can either take the diameter times pi, or you can take 2 pi times the radius times 2 pi. So either one of those will give you the circumference. Just as a quick review, I want you guys, let's go through and find these two problems. It says the circumference of a circle with the radius of 9 centimeters. So circumference equals 2 pi times the radius. So circumference would equal 2 pi times 9. I can multiply the 2 and the 9 together. It does give us a unit of measure, right? Centimeters. So 18 pi centimeters. Now, as a side note, and in the examples that we're going to go through here, it doesn't tell us whether it wants an exact answer or an approximate. 18 pi would be the exact answer. The approximate, we go 18 times pi, and that's going to be an irrational number, which means I just plugged out my calculator. It comes out to be approximately 56.5. Right? That decimal goes on forever. So we need to either choose an exact answer, 18 pi. A lot of times they'll say leave it in terms of pi, okay, or an approximate answer, which is approximately 56.5. B says a radius of a circle with a circumference of 26. This is a little bit different. Now we're working backwards. So now we know the circumference is 26, and we want to find the radius. So I'm just plugging that, the formula circumference equals 2 pi r. I know the circumference, so I plug that in there. And now I'm just solving for the radius. So in this case, I divide by 2 pi. Divide by 2 pi. R is equal to, and you could reduce this, 2 goes into 26 13 times. So it'd be 13 over pi. And our measures in meters. Now that's the exact answer. Again, you can get an approximate by going 13 divided by pi of approximately 4.1. So approximately 4.1 meters. So again, the exact answer in terms of pi. Approximate answer, you plug in your calculator and find out what it comes out to. What we're going to be doing, though, is finding the length or the distance of arcs or partial circles. So if you look at this, and let's look at this very first example here. We have, let's do this. Let's say I'm trying to find the length of this arc that I'm outlining in red. So it's a semicircle. Okay, and let's say the radius is equal to 5 inches. Okay, hopefully, just think this through, right? We know how to find the distance all the way around, or the length all the way around. That would be 2 pi times 5. So the circumference is 10 pi. Well, if I'm trying to find a semicircle, that's half of the circle. So all I do is take half of 10 pi. A half times 10, end up being 10 over 2, so 5 pi inches would be the exact answer, or we could plug that in a calculator and get an approximate. Okay, let's look at this next one. We're trying to look for patterns here, so we can maybe come up with a formula for finding the length of an arc. So now I'm going to try to find the length of this arc right here. Okay, to find the length of that arc, let's say this is 90 degrees right there, and we'll say the radius is still 5. We can do it similar to the last problem, right? We can go find the circumference of the entire circle. That'd be 2 pi times 5. So again, we know the circumference is 10 pi. Now we need to find what is the fraction of the circle we're trying to find, or the fraction of the, that arc represents. Well, this is 90 degrees right there. We know that all the way around is 360. So we know that we're trying to find 90 3/60ths of the circle. You can reduce that to 0 and the 0 reduce. 9 over 36 divided both by 9 be 1 over 4. So we want to find what is 1/4, or this arc represents 1/4 of the entire circumference. So I take my circumference, and I'm going to take 1/4 times that, 1/4 times 10 pi. That ends up being what, 10/4, which you can reduce. 10/4 reduces to be 5/2 pi. That's my exact answer, and I can plug that. I should label that. Let's say it was in inches. That'd be inches. That's the exact answer. Again, I can always plug that in a calculator, 2.5 times pi, and get an approximate answer. Just be careful on your assignment. If it asks for an exact answer in terms of pi, that's your answer, 5/2 pi. If it asks for an approximate, then you're going to plug in your calculator and find out what that's equal to. Well, those are pretty easy, both of those. Finding the circumference, and I know I'm taking half of it because it's a semicircle. Finding the circumference, and I know I'm taking 1/4 of it because that arc is 1/4 of the circle. Where it gets a little bit trickier is when you have one that's not a half or 1/4. So this one, the arc subtends to the angle, which is 100 degrees. Angle right there is 100 degrees. We're still going to approach it the same way. We're still going to find the circumference, 2 pi r. So in this case, it'd be 2 pi times r, which is 12. So the circumference is 24 pi inches. That's how far it is all the way around the circle. Now we want to find out how big is that arc right there, so that part of the circle. So what we're going to do is find out what fraction does that arc, what fraction of the entire circumference does that arc represent. To do that, we use this angle right here. So we know it's 100 degrees out of, and all the way around the circle is 360. So it's 100 360ths of the entire circle. So we're going to times that by 24 pi and work that out. So we can do a lot of reducing here, right? We could divide both those by 0. 2 goes into both of those, that'd be 5. That would be 18. We've got 18 and 24, we can reduce those. Divided by 6, that'd be 3. That'd be 4. I think we're about done there. So on top I have 5 times 4 is 20 pi. 3 times 1. So I have 20/3 pi. That would be the exact answer. And if it asks for an approximate, right, you grab your calculator and plug that in there. Let's just check and see what that is. So 20 divided by 3 times pi. Or you could go 20 pi divided by 3. It comes out to be approximately 20.9. So approximately 20.9 inches. So if you look at that pattern, here's a formula. It's just doing the same thing we just did. What it says is, if you want to find the length of an arc, what we do is we take the measure of the arc, right there, right, over 360. And that gives us the fraction of the circle we're trying to find. And you times that by the circumference, right? So that's the circumference right there, the 2 pi r. Okay, so measure of the angle divided by 360 times by the circumference, which is 2 pi r. You want to have that formula written down somewhere so you can refer back to that. Hey, as a side note before we go on here, one thing I do want to point out, if you go back to this example right here, I want to make sure we know the difference between the measure of an arc and the length of an arc. So if I take this circle and I dilate it, I make it bigger. The measure of this arc, if I ask you the measure, that's talking about the degrees. This would still be a 100-degree arc. Right? It doesn't matter how big, or if I enlarge it or I shrink it, the measure, the degrees, does not change. Now the length does change, right? If I make the circle smaller, then the length of the arc is going to get smaller. So compare that to this one now. Right, the red arc is longer. It has a larger length, a greater length. So when you think about length, the length depends on how big the circle is. So it depends on what the radius is. The measure doesn't. It doesn't matter how big or how small you make it. The measure of that arc will always be 100 degrees, but the length changes. So make sure we differentiate. When we say measure, we're talking about degrees. When we say length, we're talking about how long it is. So make sure we know the difference between those two. Okay, let's run through these 3 problems right here. This one says find the arc length of AB. So we're trying to find this arc length right here. Okay, so let's use our formula. I know I'm finding 60 3/60ths of the whole circle. we're going to times that by the circumference. The circumference is 2 pi times the radius. So I end up with 60 over 160. I can reduce that's 1/6, and 2 pi times 8 is 16 pi. We want to times those together. So I end up with 16 over 6, which reduces to be 8/3. So 8/3 pi centimeters. That would be the exact answer. And then you could plug that in a calculator to find the approximate answer. Okay, let's do the circumference of Z. So this is a little bit different. So notice that it gives me the measure of the angle, and it gives me the arc length, and we're trying to find out what the circumference is. So if I use my formula, I'm going to go 40 over 360 times by 2 pi r is equal to the arc length, which is 4.19. Well, notice this is just a circumference. Like, that's what we're trying to find. So if I could solve for this part right here, get that part by itself, I'd have my answer. Well, 40 over 360, right, we can reduce that. That would be 4 over 36. That's 1/9. So 1/9 times the circumference equals 4.19. So just times by 9, times by 9. Those cancel out. So the circumference is equal to 4.19 times 9. You plug that in your calculator, and you get, what, 37.71 inches would be the circumference. So you can, that's working backwards, right? Instead of giving us the information we need to find the length of the arc, it gives us the length of the arc, and we're working backwards to find the circumference. Okay, let's look at this one right here. So this one tells me the radius. The radius is equal to that, and it tells me the arc length, 44. And now it wants the measure, which is in degrees. So just plug in our formula. I have x over 360, right? X is the measure of the arc, times by 2 pi r. So that'd be 2 pi times 15.28. I'm going to make myself some more room here real quick. And that has to equal the length of the arc, which is 44. Okay, so now I just need to get x by itself. So let's see, I'm going to times by 360 to get that off the bottom of the fraction. And now I'm going to divide by 2 pi times 15.28. 2 pi times 15.28. Okay, now I've solved for x. This should tell me the measure of the arc in degrees. Now this is a little bit tricky. Be really careful when you plug this in a calculator. You have to make sure that the bottom part's in parentheses. So 44 times 360 divided by parentheses 2 times pi times 15.28 in parentheses. So make sure the denominator, the 2 pi times 15.28 is in parentheses. Otherwise, what I'll do is it will go 44 times 360 divided by 2, find the answer, and then times the answer by pi. We don't want to do that. So make sure the 2 pi times 15.28 is all in parentheses. Okay, we plug that in a calculator, and it comes out to be approximately, if we round it off, 160, well, if we round it to the nearest tenth, it actually goes up to 165 degrees. Okay, is what it comes out to. Hey, I want you guys to pause this and try these 3 problems, and then I'll show you, I'll give you the answers real quick, and then we'll move on from there. Okay, so for number 3, you want to find the length of the arc PQ. We would go 75 over 360 times by 2 pi r. Be careful, I'm pretty sure that 9 is referring to the entire diameter. So we have to take 4.5, which is the radius. And that's going to equal the length of arc PQ. Okay, plug it all in the calculator, and you'll get your answer there. So for number 4, you're trying to find the circumference of circle N. It tells me this arc is 61.26, so we know 270 over 360 times by 2 pi r has to equal 61.26. Okay, this is just a circumference. That's what we're trying to find right there. So if I just get rid of this fraction, this actually reduces down to be 3/4. So I can times by 4 and divide by 3. Right, times by 4 to get rid of that, divide by 3 to get rid of that. Okay, that should be my answer. That's the circumference. So I'd plug that in a calculator and I'd get my answer. Okay, number 5. So this is where it wants me to find the radius. This one it wants me to find the radius. So I'm going to take 150 over 360 times by 2 pi r. I don't know what r is. And when I plug that all in there, the length of my arc comes out to be 10.5. So you can reduce this. 15 over 360. Well, you can divide them both by 3. So it'd be 5/12. And then come up over here. So I end up with 5/12 times 2 pi r equals 10.5. So I'm going to times by 12 to get rid of that. Then I'm going to divide by 5 times 2 is 10. So I'm going to divide by 10 pi, right? 5 times 2 is 10. Okay, that right there, right? I can plug in my calculator and I get the radius. Okay, a couple application problems. This one says the dimensions of a car tire is shown below. To the nearest foot, how far does the tire travel when it makes 15 revolutions? To figure out how far it travels when it makes 15 revolutions, like I need to find out when it makes 1 revolution, it travels the circumference of the tire. So I've got to find out what that's equal to. So I'm going to go 2 pi r to find the circumference, and that'd give me 1 revolution. So it'd be 2 pi times by, let's see, if we measure all the way up, we can measure that distance all the way across. So let's go through the center, sorry. That'd be 5.5 plus 5.5 is 11, plus 15 is 26. So the diameter is 26. So actually, let's do this. Let's just use our formula, the diameter times the radius. So that would just be diameter times pi. So that'd be 26 pi. That's 1 revolution. It wants to know how far would it travel at 15 revolutions. So all we do is times that by 15. Again, you'd plug that in a calculator, and that would tell you, approximately whatever that comes out to be would be the distance traveled. Those are in inches, so make sure you know your measurement, right? Whatever we get is measured in inches. We're going to skip past that one. Actually, let's go back. Let's actually do this one. This says the curve of a track are shown are 180-degree arcs of circles. The radius of the arc for a runner on the red path shown is 36.8 meters. So that tells me the radius. How far does the runner travel to go once around the track? Okay, so let's just add all this up. We know from here to here, they travel 84.39. They'll also travel that straightaway over there. And then it tells us that this part right here is a 180-degree arc. Well, that's a semicircle. This side is also a semicircle. So together, that arc and that arc make a full circle. So I can just go not equals, but plus 2 pi times the radius, which is 44.02. Okay, plug that whole thing in my calculator. 84.39 plus 84.39 plus the circumference of that complete circle, 2 pi times 44.02. We'd plug that all in my calculator and then give me the total distance all the way around. Okay, so you're just practicing again finding circumference, which we all know, but you're adding to that finding the length of an arc. And just be really careful we differentiate between the length of an arc and the measure of the arc. Measure is in degrees. Length is measured in, in inches, centimeters. You're measuring how long it is. Okay, thanks, guys.